Hello everyone, and welcome to another one of our Siemens Solid Edge Portfolio webinars. This one is titled How to Create Lighter, Stronger, Cheaper Products with Generative Design, and it's part of a series of digital transformation webinars focused on speeding your product development and manufacturing process and helping you deliver world-class products to your customers. My name is Kevin Grayson, and I'm your host and presenter for this webinar. I'm also joined by John Sutcliffe, who is also presenter for today's topic of generative design. In the interest of time, we'll not have a separate Q&A session at the end of the webinar, but you can key in your questions to the Solid Edge Community Forum shown at the end of this webinar, and we will get back to you and answer your specific questions. The Solid Edge portfolio is focused on driving digital transformation for small and medium-sized companies. We see that these companies want complete, fully featured, and professional engineering tools, but they also need tools that are easy to access and easy to learn. As you'll see in the webinar series, the Solid Edge portfolio is more than just a Solid Edge CAD product. It's a complete portfolio of solutions of design, simulation, manufacturing, and technical publications. Also, we have tools for collaboration and data management. Combined, these speed the complete product development process. With the Solid Edge portfolio, you can create detailed 3D digital models, also known as a digital twin, of your proposed products and use this as the basis for all areas of product development, including concept and detailed design, prototyping, simulation, manufacturing, installation, and service. This digital twin also helps small and medium-sized business manufacturers address major challenges like increased complexity and increasing regulations. So what exactly is generative design? You may have heard terms such as topology optimization or shape optimization or generation. We prefer generative design because the computer helps to generate the design for you. Think of this as true computer-aided design. It's generating the optimum design between weight and strength. This process usually results in a uniquely organic shape and something aesthetically very interesting. Let's start by introducing generative design by comparing it to traditional design. With traditional design, the first step is to understand the requirements for the design, and then to apply good engineering practices and your experience, and use traditional 3D CAD software to design a shape that meets the requirements. Then you validate the design using computer-based stress analysis and/or using physical prototypes, and you may then need to loop back and modify the design. With generative design, however, the first step is the same. You need to fully understand the design requirements. But the next step is to input these requirements to a generative design study, and then use the software and the computing power to create the best shape that meets the requirements. Validation in terms of stress analysis is performed as an integral part of the generative design process. Let's look at the potential benefits that generative design offers to manufacturers. The first is the possibility to reduce cost per part by reducing the amount of material used in specific components, and therefore material costs. This is particularly important for parts manufactured in high volumes, but can have a significant impact even on batch production and one-off parts. The second is the opportunity to reduce your manufacturing costs. Generative design results in a single solid mesh body that can replace a multi-component fabrication such as a welded assembly. This reduces your need to spend money on jigs and fixtures and on welding materials and highly skilled welders. These single body parts can also be manufactured using the latest additive manufacturing techniques. This reduces the need to design and manufacture expensive tooling. It also creates unique, organic-looking designs with an attractive appearance that help your products to stand out from the competition. You may have seen other tools on the market that perform topology optimization. The difference between those tools and Solid Edge with generative design is with the other tools, they may run for a little bit, create a really ugly model with lumps and other weird stuff, but then the designer has to go in and create a beautiful model only using the topology optimization as a visual guide. That may work for some, but that, however, is not the state of the art. What you see on the screen now came directly out of Solid Edge generative design, and there's absolutely no post-processing on these models whatsoever. They come out complete, that beautiful, and ready for production, straight out of the system. Today we're going to look at a specific customer case study from Hall Designs. Their task was to design and manufacture a new gas pedal assembly for the Herb Smith racing team. This racing team has developed a unique traction control system for their race cars that gives them a competitive advantage. The gas pedal mechanism is a critical part of the traction control system, and it connects the driver with the drivetrain. One of the specific design goals was to replace the current gas pedal, which is a 6-component welded assembly, with a single body component. The welded assembly required specialist welding labor, and if not welded correctly, could be subject to failure. The new gas pedal needed to be lightweight but robust, and had to be designed, manufactured, and delivered in the space of 4 weeks. Let's take a look at solid edge generative design in action.
Let's consider this mechanical pedal assembly. Currently, the pedal itself is an assembly made up of about 6 separate fabricated parts. This can be expensive to produce. Our interest is to reduce material, weight, manufacturing and assembly costs, but at the same time ensure structural integrity. This is a perfect application for generative design. To start with, we'll replace the pedal assembly with a basic shaped model. By moving the pedal in its range of motion, it becomes apparent how this design is supposed to work. It helps us to better understand what aspects of the part's geometry are important for the pedal to work correctly. Now we have a better understanding of how it works, we can begin to set up the generative design process for this part. We'll edit the part and turn off any background components. This lets us focus more on the design of the part itself. Generative design is fully integrated into Solid Edge, and all the commands are right at your fingertips. The ribbon presents the 10 key commands for generative design in a logical sequence, guiding the user through the steps they need to complete in order to set up and run a generative design study. First, we just need to ensure a material is defined. Once a study is created, we can then go through the process of selecting preserved regions or areas of the model we want to keep. Here we can define an offset value, which will preserve the hole and the boss geometry. It's obvious where the force is to be applied on the pedal. The direction of the force can easily be set by using the solid edge steering wheel. The value of the force can be defined along with an offset. The final thing to do is to set the constraints on the model. For this study, we'll set a fixed constraint on both holes on each side of the bottom pocket. Again, we'll define an offset. We'll also fix the rear pivoting boss. Remember, the option to define an offset helps preserve the geometry in the part needed for it to function properly when finished. After defining all the study options, we're ready to generate the new design. The Generate dialog provides slider bars so that you can make a quick adjustment for study quality and a target mass. For this first example, we'll reduce the mass by only 20% to give us a baseline. Allowable stress values are shown as well as a factor of safety. Let's generate the model. Once generated, we can take a look at the results. Here we can see the areas of the model where the stress is most concentrated, just below the pedal. Remember though, we're still within the allowable stress for this part given our factor of safety. We can run the study again and make some adjustments. Here we'll reduce the mass a little more by changing it to 40% to see what the results look like. Immediately we can see most of the material removal occurs under the pedal. Depending on the user's preference, multiple studies can be created and each study's settings are easily accessible through the edge bar for quick changes. This iterative process to generative design makes it easy to adjust any parameters in order to get the best possible design as fast as possible. Before generating the last study, let's make a quick change by preserving the sides of the pedal in order to give it more strength and stability. Once again, this is just a case of picking the required geometry and entering an appropriate offset value. This time we'll also reduce the mass of the part by 60%. Notice the result shows a huge reduction in material, and yet the super smooth mesh model has enough strength to withstand the forces it will be put under during everyday use. Displaying the background parts in the assembly, gives us a clear idea how the new pedal fits within the design and interacts with the other components. The huge advantages in using Solid Edge to create and work with these generative designs, which are essentially mesh models, is when it comes to the creation of additional features that the design may need. With Solid Edge, adding and removing material is simple and fast. For example, a cutout can be added to the lower boss for the purpose of placing a bushing. The use of standard modelling tools make this process quick and easy by picking up on background parts in the assembly. We'll also add some geometry too. In this case, we'll add the part number to our part by first placing text, then extruding that text into the design. The power of Siemens Convergent modelling techniques available in Solid Edge provide an engineer with the ability to further the design of mesh models fast and easy. Returning to the top level assembly, we can see the finished design of the pedal in motion with the rest of the assembly. So generative design gives us the capability to generate low-cost, lightweight mesh models that can then be modified through convergent modelling techniques. The only question that remains is how can we manufacture these models? Let's go back into the new pedal design and answer that question. Solid Edge provides the capabilities for you to take your designs directly to the additive manufacturing process. The 3D Print tab provides several options to get your designs manufactured. We'll start by previewing this model. This allows us to check on its quality and then adjust the tolerance of the facets if required. If you have access to a local 3D printer within your company, then your part can be printed right from your desktop. Here's an example of reading our design into the Fabricam 3D printer. The step-by-step approach first allows us to change the layout of the part so it's in a better orientation for printing. The Settle option uses kinematics to drop the model onto the printer bed in the best orientation. We can define the quality of the print, review any overhangs where support material may be needed, select a material, and finally make changes to advanced layout and settings. Now your in-house printer might be ideal for creating one-off prototype parts in plastic materials, but what if you don't have such a printer available or you want to choose the best material for the final part, including, for example, steel, aluminium, tungsten, ceramics or wax? Solid Edge offers the capability to order the 3D print through an online service called Through Your Mind. Through this interface you can check the printability and scale of your model, then browse through the different material options, using filters if necessary. These all include the price, print method and lead times. Once we select a desired material, we can then choose which preferred company we want to use for the actual 3D printing. The idea here is to give you all of the options needed so that you can get your parts printed as quickly and as cost effectively as possible. When you think about next generation design, think about Solid Edge and the state-of-the-art next generation tools it offers to get your job done right first time. From generative design for creating a lightweight, very smooth mesh model, to convergent modelling, which gives you the capability to further the design and easily edit the mesh model, to state-of-the-art 3D printing capabilities.
Thank you, John. So to summarize the results of the Hall Design's generative design case study, they had a prototype created in plastic using their in-house 3D printer. The prototype was used to assemble the part alongside the other components to prove out the fit and function and for customer review and approval. The final production part was then created by submitting the design to an external additive manufacturing specialist. They printed the component in aluminum using a select metal sintering technique. The final component was actually 25% the weight of the original. It had an excellent surface finish, and the high-density sintering process also results in a very strong part. In the demonstration today, we showed the power and benefits of using Solid Edge generative design. But there is another key element to this technology that was briefly demonstrated that I would like to reiterate for the next few moments. So we mentioned the generative design is a mesh body, STL, OBJ, etc. And we showed how these types of models lend themselves well to additive manufacturing or 3D printing. But what about the other stuff? What about the other data that was created with traditional 3D modeling technology that we want our generative design to be incorporated with? In most systems, mesh data and BREP, or traditional solid model data, are not interconnected at all. So here's the challenge. Our generative design gives a great answer, but what if I need to change it or add to it? Also, our additive manufacturing is awesome, but what about the awesome designs that drive it? So we ask ourselves, what if I could work directly with my mesh model? And what if I had an awesome ready-to-print model, but could still add or subtract features? The solution to this is Siemens Convergent modeling. Convergent modeling allows you to combine and use mesh models and BREP models in one seamless environment. You can work on your mesh models with the very same commands you use on BREP. As an example, on the left we have our generative design that created the mesh model, and we want to incorporate that into our existing design on the right. To do so, it requires a few little changes. It needs a counterbore hole because of the way it connects to the stand. A rod passes through it, so it needs a cutout for that penetration. So before starting the video for this next example, I want to caution you that it looks like basic solid modeling, what you're probably used to. But the fact is, this is not a solid model. With Siemens Convergent modeling, you can use the same commands you're used to make the necessary changes. Here in the video, you can see a sketch can be created to form a region that can be easily dragged to remove material to form the counterboard. Next, a cutout extrusion is created to form a flat where a part number can be placed. Emboss the text quickly, and you're done. Finally, the cutout for the rod is placed, and in fact, it's parametric. The last thing is to just replace the original clunky design with our new lightweight, highly optimized generative design. As we come to a close for the webinar today, just a reminder that the Solid Edge portfolio is focused on driving digital transformation for small and medium-sized companies. Again, Solid Edge is not just a Solid Edge CAD tool, but it's much more. We have the very latest and next generation design technologies, including generative design, alongside of simulation, manufacturing, technical publications, and many more. You can download a trial version of Solid Edge at the link shown here, and this includes the free version of Solid Edge Generative Design. Or you can contact a local channel partner to learn more. For existing customers, you will have access to the free version of Solid Edge Generative Design in Solid Edge Classic or Solid Edge Premium, and you can purchase Solid Edge Generative Design Pro to access the full capabilities. Once again, I'd like to thank John for his awesome demonstration today. If you would like to find out more about Solid Edge, you can call this number to speak to us directly. Or you can use this link to download a trial version of Solid Edge that you can use free for 45 days. Thank you very much for your time and attention today, and we'll see you next time.